Alright, so in this video, we're still going to be focusing on 4.2, but we're really just going to focus on graphing and seeing how that relates to the domain and range of a parabola. So remember, you don't have to write this down because it should be in your 4.1 notes. The domain is the set of all x values in a graph, and the range is the set of all of your y values. So let's just look at this by taking a look at the example of y equals x squared minus 8x plus 21. If I want to graph this, I really need to know what my vertex is, which in class we're going to learn how to do this on the calculator, but if you want to do it by hand, you do the negative b over 2a, which is going to get you the x value of 4. Then what you would do is plug 4 in to your whole equation here. Do 4 squared minus 8 times 4 plus 21, and that's going to get you 5. So then I'll plot 4, 5 on the graph. Now, what we did before in class is we used the a value. My a value in this graph is 1. I typically would count up and over. But what we're going to do in class tomorrow is we're going to actually do this by hand and see how this works out. So if I want to go to the next coordinate on either side of my vertex, I'm going to see where I'm at 3 and 5. So similar to how I found the y coordinate in the vertex, I'm going to plug 3 into my equation, and I'm also going to plug 5 into my equation, like this. When I calculate this, so when I do 3 squared minus 8 times 3 plus 21, and when I do 5, when I plug that in, I'm going to get the same value on either side because this is symmetrical. Both of these are going to come out to be 6. So if I did up 1 over 1, that would still give me the same coordinate as well. Now the new thing that we're also going to do here is we're going to find the coordinate 1 even more out. So now I'm going to find where I'm at 2 and 6. So again, same thing that I did before. I'm going to plug 2 and 6 into my equation, and it's going to spit out my output or my y value. So I'm going to plug in 2, 6. It should look like this. And I should get 9 on either side. So you could see here, differing from an absolute value equation, I'm increasing by an increasing rate. Now I jumped from 6 to 9 instead of jumping up 1 again, making my start of a parabola because it's increasing by an increasing rate. And my parabola would look something like this. Also, something that you want to notice here, more importantly, how this ties into range. Notice how my vertex is at 5, and this is a minimum, so my vertex is my lowest point. As I go to the left of the graph and to the right, my values are just going up on either side. So 5 is going to be my lowest coordinate regardless of what x value I put in. When I go to the left, I'm going upwards, and when I'm going to the right, I'm also going upwards. You could see this if we kept taking coordinates out, which I'm not going to expect you to do, but let's just take a look at this here. Now you don't have to write any of this down, I just want you to watch and see what happens. So here is still my graph. This is the same equation, y equals x squared minus 8x plus 21. My vertex is at 4, 5. And take a look at what happens when I take out these numbers even further. So instead of just going from 2 to 6, I took it out a couple more coordinates. Again, 5 is my minimum point. As I go to negative infinity for x, I'm moving up. And as I'm moving the other way, as I'm getting higher x values, my values are going up as well. If I take this out even further, the same thing's occurring. Now I'm up in the hundreds, but 5 is still my lowest value. And this is going to happen because since I'm dealing with an x squared, even if I plug in, like, say, negative 21 for x or positive 29, I'm still going to spit out a positive value, which again is why this looks like a parabola shape. If I take this out even further, you'll see the same thing happening. No matter what x value I plug in, my y values just keep getting higher and higher and higher. I'm going towards infinity for my y values or for my range, but I'm my lowest point and I bottom out at 5. So basically the main takeaway from this, you want to write this down. If I have an equation where my a is positive, so I have some graph that looks like this. For my domain, my u is just going to go bigger and bigger, or it'll keep getting wider as I keep going out. So my domain for all of these graphs is going to be all real numbers or from negative infinity to positive infinity. But when I look at my range, my lowest point is going to be my min, and in the example that we just saw, as I go up higher, I'm just going to keep going and going and going until infinity. On the other hand, when a is a negative value, let's say I have a graph that looks something like this, my domain is still going to go from negative infinity to positive infinity. There's no stipulation on that. But now I'm going down for forever, and my highest point will be my max. So my range, my a value is negative, will go from negative infinity to my maximum value.